I'd like to welcome Dr. Cvetanovic.
Yeah, very good.
Excellent. Go ahead and stand up and stretch while we switch slides around. I know you guys have been sitting for a while. All right. Shake it all around.
Okay, everybody, thanks for coming. And I am one of those academics who do research that you just heard about 2 previous talks. And I'm going to tell you my career story. And I think telling about career path is not, as we just heard Dr. Schaefer say, is not because we are all unique. Everybody has different paths. It's just what is general about those things that are take-home messages. What things you can learn from people who went through their career path. And that's what I'm going to try to focus my talk on, what I have learned to be true about career that may be helpful for you guys. And let's see if I can first figure out how to use this. Yes. Okay, so I did not start 30 miles away. I started many, many miles away in something that was called former Yugoslavia, which most of you have not heard from. And I'm actually going to start even at the age younger than what you are. When I was in elementary school, I lived in Bosnia in a really small town. And I love mathematics. That was my passion. When I had pure talent for it, I had a great teacher who would spend time working on problems with me. And even though I was from a really tiny town, I managed to win some awards because I really loved it. And then I heard about this special school called Mathematical Gymnasium in Belgrade. So I actually left. I'm sorry. Oh, you cannot hear me. Okay, sorry, guys. Okay, so I actually left my hometown to go to high school in a completely different town. I wanted to go to that school because it was focused on mathematics heavily. So we had several. I know it may be sounding crazy for some of you guys, but it was really great for me. And there I met many different teachers that I really am grateful for because that was kind of experimental program and they really taught me how to think independently. So just use your time in high school to learn how to think critically about the things teachers are teaching you because that is awesome. So had many great teachers in my high school. One teacher that was particularly influential was my biology teacher who decided to teach us molecular biology. That was very new at that time. And it influenced somebody who loved mathematics to go and then study molecular biology at the University of Belgrade. So I switched my passions at that time, at the stage of the high school is where you are. And that all happened to be actually kind of really that I went to Belgrade was good because my country kind of fell apart during my high school. So we had civil war, so the part that I used to live, my parents had to leave it and we became refugees in the place where I was actually studying already. So it was good for me because I didn't have to change the school and then I could continue going to the university. So it was as little as possible disturbing for me. But again, teachers were the ones who steered me towards the path that I kept going on. Now, because there was a civil war and inflation rates of over 200% per day, so I realized that I actually cannot probably do science in my country. So I decided to come here for a graduate. I really always knew that I want to do research. So that was something that I realized early on in my studies. So I took a plane and came to the United States to do a PhD in immunology at the University of Illinois at Chicago. I didn't come by myself. On this plane, I came with a 3-month-old baby. So you can do stuff, and even with the family at that early stage. And one thing that I learned having family and doing a PhD study is that not being loved is awesome, but loving and caring for somebody is probably even more awesome. It gives you that inspiration to do way more than maybe you would think you can do. So that's why I'm saying family is really critical. That support is really critical. So after I completed my PhD, again, as I said, I knew I wanted to stay in academic track. I went to do my postdoctoral work, and that's where I started working on neurodiseases, on diseases of the brains. And that then led me to come here to this beautiful town to my dream job, studying the guardians of the brain universe. These are not exactly the guardians I'm studying. These are the guardians that I'm studying. So most of you, and I don't know why is my dog's picture upside down, but that's my guardian. But we are talking about the guardians of the brain universe. Most of you have when people talk about brain, they talk about the neurons. But neurons are really just 50% of the cells in your brain. The rest of the 50% of the cells in your brain are glial cells. They come in the form of astrocytes, star-shaped cells. That's where astro comes from. Microglia, which are the major cleaner of the brain. They actually clean everything. And then oligodendrocytes that actually make the signalings from your neurons go really fast instead of really slow. These cells are key for the brain function. They really support neuronal function. They are kind of neuronal parent, and they also can help in disease. So that's actually what we are studying in my lab, is how these cells can help fight brain diseases of the brain. I am in particular interested in one disease called spinocerebellar ataxia type 1. It's neurodegenerative disease. It's inherited. That's shown here by two brothers who, unfortunately, because they're twins, they both inherited disease. Ataxia comes from Greek, lack of order. So lack of order implicating they have trouble walking, which you can see here. In the initial stages of disease, you may be just stumbling. Then you have to start using the cane or the walker. Eventually, these patients are wheelchair-bound and they die prematurely 10 to 20 years after the onset of the symptoms, and we do not have any therapy for them. So research in my lab is trying to understand this disease and also how to see these glial cells that I mentioned you. This is one of them, astrocytes. This is image from my lab, and it's video, but I don't know whether it's going to play here. No, it's not going to play here. Okay. And it's sitting right next to these Purkinje neurons. You had a beautiful image from Raman and Cajal in the first talk. So Raman and Cajal really like Purkinje neurons because they are gorgeous. You can see these neurons are just most beautiful. Well, I'm subjective. They are near and dear to my heart, but they are really gorgeous. And this cell that I study, Berman glia, is really intertwined with that. So it really is at the right spot to help this neuron. And the research in my lab has shown that actually, indeed, these cells can help neuron continue to function in disease to delay the onset of the symptoms. So they are really important and they can play an important role in disease. So that's what we are trying to study. But the real heroes are not being able to pull out that photo. Okay. For some reason, this doesn't look exactly as it does when I was making. But in addition to, so my dream job is research. But in addition to that, I do teach and we do service. And this is the part that I also like. This is something for you guys. We talked about how you can get research experience. You can get it even in a high school coming to the U of M. We have organized at the Department of Neuroscience, this last year was our first year for Go for Brains. If you go and look for it, search on it. This is a program for high school students. We bring the students for a week. They get to learn about career in neuroscience, but they also get to spend time in the lab and meet undergraduate students, graduate students, and faculty. So you can learn more about careers and how can you get more research experience. I did have a picture here, which is missing for some reason, in which you will see the real heroes in my lab, in which you will see that this research is done by high schoolers, undergraduate students, graduate students, and postbacks, which are the students when they're done with the undergraduate and then they're thinking what is the next step of the career. Do they want to go in the research? So they spend a few years doing the research in the lab. So we have in the lab people at different stages. And if you want to do research as an undergraduate, you really just send emails to the faculty. And I receive those emails and I meet with everybody who sends the email and explain them what the research in my lab is. Okay, so check this if you're interested. We are going to have another round of applications. They're usually due in March. And we provide the stipend as well because this is mostly for students underrepresented in science and medicine. So what are the key things that I learned? One is expect obstacles and problems. You know, as I said, there was a civil war. There were lots of bad stuff happening. And not all of them you will be able to make possible. But that's not the point. The point is that you try to solve the problems in which you have come. And if you succeed, awesome. If you're not, you gave your best to try. Teachers and mentors are really key. They can help you. They can teach you new things. They can help you get much better in the things that you really are interested and passionate. What we heard also from both of the speakers, find what you love, and that's where the teacher can help you. And you know what you're curious about, that's what you want to do in your life. That's what's going to inspire you to go through every morning when you wake up in the dark, as we have right now. You really want to get up and go and do that work and interact with those people. And that brings me huge joy. Try new things. This is climbing, but when I meant new things, it can be climbing, but it can be any intellectual things. Try them. see how much you like it. When the door opens for something new, go through that door. Again, I went over the ocean to come and see it, and it was pretty frightening with a 3-month-old baby in completely new country. Things can work out. Just try them. And family support, I think, is immeasurable, Walt. And when I say family, I mean in the broadest possible manner. Not just your near family, but it can be your pets. And it can be also, and again, I am missing the photo of my lab. It can be your lab friends, people who you work with. They are all your family, and all of each other's students that you are together, friends, they're also your family. You can support each other, to get where you want. And that's all I had to say. So I can answer any questions you may have.
Great, thank you. Any questions? All right, well, I'd actually like to ask a question of our 3 fabulous speakers. Can you talk a little bit about being a woman in science and what that's like and what obstacles?
You can start, please.
It didn't occur to me that I was anything different until I got, it was probably like year 10 at Medtronic, when I got invited to do it was a special course for leadership for just women. And I asked my boss, who was male, I said, did I do something wrong? Is it punitive? Like, am I in trouble? Do I not get along with females? It honestly didn't occur to me. I know that that's not the scenario that everybody else has. I just didn't really notice it because I didn't care. And I guess it served me well. But if that's not your experience and you need any help there, I am wide open to listening. So and trying to help how I can. So I'm not answering the question really great, but if you're experiencing a pushback on that in any way, or you think it's awkward to be a female in science, my first suggestion is don't care. Screw it. Because it's so awesome being a neuroscientist. Hey.
I had similar experience, but I think the culture also changed. I think maybe that was, I think that was much bigger issue even 10, 15 years ago, but now I think there are more and more neuroscientists, or scientists in general, who are women. So I think we are paving the road well for you guys. So hopefully there will be nothing to talk about it when you come to our position. That is my hope.
Yeah, I would say my answer is it's never been better to be a female in research and science. It's I have had some experiences like that didn't really register to me till later. Like I was always asked to organize something, but I always used those opportunities to also make sure I was sitting at the dinner table with whatever executives were visiting for whatever reason. So there were things that I just didn't register. I was being asked because I was the female PhD student, or I was the female in the room. I also had an incredible experience at Cala Health where we were a Silicon Valley startup company, but we were like 70% female. So that was a very unique experience, and I think we're seeing more and more of that as I think women become more confident that we can do this, and we're good at this.
And majority of our graduate students at the program of neuroscience are actually female. Just so you know.
One thing it reminded me of, thinking about your family, I was going to mention, I did experience in grad school, I went in to talk to a PI, which stands for principal investigator, or just, a faculty person. I said, I have an issue. I want to talk to you about it. She goes, what, you're pregnant? Like, would that be a problem? It was really a surprise to me, and I didn't think about much of it at the time. But there is that, I think, in academics and early career scientists. Right. You're like, here I am. I have twins. I'm 43, no, I'm not. I'm 48, almost 49 years old, and I had them at 43. And so I spend a lot of time in my career before having children, and that worked for me. But I love to see that, there's so many others that do it a different way. So do what works for you, and go do family, go do your career, go do what you love.
Great, thank you so much. Let's hear it again for our 3 presenters.